We're getting close to the end of the class, so before we go, let's go over how we can take our new skills further. Autoencoders are a great next step after mastering embeddings, as they're closely related. Like embeddings, one of the goals is to take higher dimensional data and be able to represent it in a lower dimensional space. Here's our strategy. We're going to make a model that's a mirror image of itself with a lower number of neurons in the center. Then, we're going to take our input and also use it as our output when training. As an example, in the above, we've taken a flattened image and we'll train this model to output the same flattened image as what was inputted. Why would we go through this complicated process if we're going to get the same thing as what we entered? Check out this magic. After we train the model, we're going to cut it right after the middle. And we'll get an encoder and decoder. There are a couple of great uses for this. If our model is accurate, we can store large amounts of data with only a few numbers, and we can restore the original data if and when we ever need the raw data format. The other use for this is for something called anomaly detection, which is useful in security, fault detection, and medicine. If we train an accurate autoencoder on lots of data, but there are some data points for which the output is significantly different than the input, then we might consider that an anomaly that we need to pay more attention to. Not long after the invention of autoencoders came variational autoencoders, which we can use as generative AI for images. We could train an autoencoder on images so that we can use the decoder to generate images. Similar to variational autoencoders, but much more complicated, are diffusion models. Diffusion models work by taking a noisy image and slowly subtracting small amounts of noise at a time until an image is formed. It's the neural network equivalent of an inkblot test. Diffusion models are the basis for many famous image generation tools, like Adobe Firefly, Stable Diffusion, and DALL-E.
So this one's my personal favorite. It's called reinforcement learning, and it applies so much to being a teacher. So let me take an example of this dog here. This is my sister's dog, Penny. So Penny has a treat on her nose, and it's very, very tricky to teach a dog this trick to not eat the food because it wants to eat the food immediately. But Penny has learned that if she waits a little bit, she'll not only get that treat, she'll also get another treat. And that's what reinforcement learning is all about. It's this idea of being able to learn rewards over a different period of time spans. So this one can be used for training robots, and it's kind of interesting to think about. If the robot does the right thing, we can give it a cookie, and if it does the bad thing, we slap it on the wrist. And over time, it'll learn the behaviors that we want it to learn. All right, one last thought before we go. I like to finish all my class on sort of a philosophical note, something just fun to think about. So here's the hypothetical question. When do we know that machines fully understand the concepts that we're trying to teach them, as opposed to just copying a set of instructions? Here's a hypothetical situation. Let's say that we're stuck in a room and it's just full of books relating to rocket science. I'm not a rocket scientist, I'm an AI teacher, but in this hypothetical room, people are slipping equations under the door for me to solve. Now what I could do is, because I have this huge set of books based on rocket scientists, is I look at the equation, I find the book that matches it, and I just copy the solution through the book. Then I slip the equation back under the door with the solution. Now the people on the other side of the door, they're thinking, wow, this person knows all sorts of great rocket science stuff. But in reality, I'm just copying the solution. With these types of Turing-like questions, I like to flip it around and think, how is a human not like a computer? When do I know that I fully understand a concept? So I'll let you think about it for a bit and see if you can come up with an answer to that. There is no right or wrong answer. However, the people that can describe what understanding truly is, and not only that, but can describe it in a way that a computer can understand, are the ones that make the biggest breakthroughs in artificial intelligence. Okay, that's all I have for you. Thank you so much. I had so much fun making this class. Good luck in your journey.